My name is Stephen Pulliam. I've been teaching for over 20 years, many different subjects, but mostly chemistry along the way. Been teaching AP chemistry for about 11 years, 11, 12 years now. I'm a table leader for the AP chemistry exam. That's a role that I enjoy very much. Head off to Salt Lake City, Utah with about 320 or 330 other teachers to grade the AP exam every year. And I found that to be a wonderful experience, professional development, building relationships with other faculty, learning more about the test. It's just been a very good experience. If I can put in a plug for that now to encourage you to apply to become a reader if you haven't already, I definitely think it would be an experience that could be very valuable for you. But tonight our focus is on using AP Insight to develop enduring understandings. As teachers, we all want our students to not just know the material for the test and for the course, but we want them to know that material, to know that information beyond, right? We're preparing them for the next steps, which is college and then beyond. And hopefully we can push our students and challenge our students to do that. And that's what we're going to focus on tonight. If you have your microphone working, which April I saw that you're not sure how to get that working, not to worry. You can participate through the chat window, and that will be fine. I'll be checking that all evening, and I'll see that. And if I don't see it, you can also raise your hand. There's a little icon at the top of your screen. Little person raising their hand, just click on that, and that will draw my attention to that you've got something to contribute. So I hope that you're able to this evening. I'm glad that you can hear me. We're going to try to share our knowledge. We've all been using AP Insight, I hope. And in fact, maybe let's take a minute, Maria. I know you've already put some information in there about how you're using Insight. April, could you just tell us a sentence or so of how you're using AP Insight, how long you've been using it, how you found it effective?
Can you hear me now? Hello?
Yes, I can, I think. Yes, hello?
Okay, I think that's me. Do I need to get a little louder?
A little bit, yes. You're kind of soft. Is this Audra speaking? Or was that April speaking?
April.
This is April.
Oh, there you
go. Yes, we can hear you, April. Excellent.
Okay, I have been teaching AP for like the last 3 years. I just started with AP Insight this year, and unfortunately I haven't used it much. My class is in place. I'm excited to use it, but I've been in a place where like I've been doing a lot of stoichiometry stuff and a lot of gas law stuff, and there's very little on that topic. And so...
Right, yes, I agree. I'm in gas laws right now myself, and have not been able to use it recently.
Hello, can you still hear me? So there's very little on that topic,
yes.
and I'm
yes,
so I'm excited to use it. I want to use it. I'm just trying to get there.
Great. Well, hopefully tonight we'll be able to give you some tips and point you in the right direction, so that when the challenge areas line up with where you are in the curriculum, you'll be able to jump right in.
Yeah, I guess my I'm sorry, I have to like raise my hand, right? Like
Oh no, go ahead. There's only 3 of us, so.
Okay. I guess my situation is different because we are on a block schedule, so I barely have like maybe like 3 more weeks with my students, and then I'm not gonna see them again, not until like 2 weeks before the exam in May. So I basically like covered almost everything already. When we yes, it's like in one semester we have to fit everything in. So when I started in September, just review on stoichiometry, solution stoichiometry. So by October I was already doing kinetics, and then November equilibrium, kinetics, and then thermochemistry, and then equilibrium, and then acids, bases, buffers, KSP, solubility product constant in December. and then thermodynamics like last week, first week of January, and now I'm going back to like chemical bonding, like just going back to like what they've learned in their first year chemistry. So basically, my students, they have like gone through most of the tasks that are like in AP Insight.
Okay,
Uh,
and you'll use AP Insight a lot when you begin reviewing. Did I hear you correctly?
Yes, that is correct. We really use it a lot, especially because it is available online, and some of them they cannot come to me for review after school. So that is my only link with them. Like I will like open the quizzes, I will open the assessments, and then they can do it on their own, and then at least I can see how they're doing. Did the student they complete the quiz? What is his or her score? What is the topic that he or she is having difficulty with? So it's
Mhm.
been very, very helpful in that way. Yeah,
Good. So is this your second year using AP Insight?
that is correct. This is my second year of using AP Insight.
Great. So we're gonna expect to hear a lot from you tonight about how you incorporate those resources as we start looking at some of them tonight.
Okay.
All right. So tonight, here's kind of the overall. We're going to talk about what enduring understandings are. We're going to look at the connections there with AP Insight. Then we're going to spend some time looking at a specific challenge area assessment, representing and modeling energy. And then at the end, we'll have a little time to share and ask each other questions and hopefully have some rich discussion at the end of this. So let's go ahead and dive right in. Enduring understandings. Right? We've all done our syllabus, and we've got big ideas, and we've got the enduring understandings, right? And those are the core concepts that students should retain from the learning experience. And even without labeling it enduring understandings, I think we as teachers know that we want them to understand this material and beyond just the class.
Mm-hmm.
Right? We want them to be able to take it to the next level should they take science in college and chemistry in college specifically. And so we want to give them a good foundation. We don't want them to just know this information just for the test.
Mm-hmm.
Right? So the enduring understandings support the essential knowledge. They're supported by the essential knowledge statements. Right? And as we look through the curriculum framework, we can see kind of the layers that the College Board has spelled out. And it just makes a lot of sense to me as I, every time I go back and look through that, the organization of that just seems to make sense. How do we know as teachers, though, how do we know when a student understands something versus them just kind of knowing it?
For me, the way
And I think that's hard to determine. I think that's probably the hardest thing for a teacher to determine. When have they mastered it versus when can they just regurgitate it, kind of thing.
Right. Sure.
usually like they would say that they know it. They will be able to like give the definition of the terms. So what is pH? What is an acid? What is a base? Like, but given, for example, like a chemical equation, and then you ask them which ones are the conjugate acid-base pairs, they're lost already. Or like sometimes also like in terms of like knowing something, some students are very, very good in math. So they can actually memorize the step-by-step procedure of like how to solve a particular problem. Or like for example, like calculate the pH of a weak acid given the concentration and the Ka value. Most of them, like they know, oh, give me this particular problem, I know how to do it. But if you tie it with like a titration curve, for example, and then tell them at this point in the titration, how would you calculate the pH? They do not know how to do that anymore.
Right.
So I think like, as you said, like April, like they can regurgitate the information, like usually like teachers who give it in like a lecture type of like classroom, sort of like just what do you call that, like transferring it as if like the students are like a sponge, like absorbing the information. But to actually like make connections between different concepts and then you try to like give a different example, then they cannot transfer the learning anymore.
Right. So it
Right, I
certainly
agree.
is a challenge to get there, right? What are some
Yes.
strategies that you guys have used in your own classrooms, even outside of AP Insight, to address that, to get students to be able to explain or interpret, right, or deal with a problem that's just that's different than the one you just gave as an example?
Well, I'm finding that for me, it's even in my first year class, it's going back to how do you explain things? They've never had to explain the answer. They've always had to just throw up on a piece of paper this answer and it was right or wrong. And so teaching them how to explain that and what are the essentials to explaining that. And then for my AP class, it's really, supporting them by saying, okay, so giving them foundationals and showing them, okay, how do you approach a problem? How do you break it apart? How do you then apply what you know? And really teaching them those steps, because I don't think that they've learned that or that they know that.
Mhm. Yeah, in the past, like when I wasn't like using AP Insight yet, like I used to like give them handouts, and it became more of like transfer of information. And by the time we are in December, January, all of the concepts are already scrambled. Like I mean, they mix up the concepts already. But I found like last year and this year, I really advocate the building block framework, or like the building blocks that you have in like AP Insight. Like before they actually go to the more complex concepts, okay, let us start with temperature first. What is your understanding of temperature? What is your understanding of heat, for example? Before we go into like calculating already, oh, Q is equal to MC delta T and so on, and then they don't know what is Q. Like, I mean that's I think like the way the concepts are like, or the challenge areas are like designed in AP Insight, you really go to the, as you were saying, April, like go to the foundation first, which is like the basic concept for that particular area, and then move on from there. And then the other thing that I think has been very effective is that instead of me like transferring or like lecturing, like explaining, it's now more of them doing the explaining. Like because there's a lot of like guide questions wherein they have to answer the questions, and then from there they're trying to build their own understanding. And then when they are explaining, then I catch it like, oh, hang on, like what you are saying is not correct in terms of like this particular concept. Do you follow what I'm saying? Like because when I'm the one doing the explaining, it is hard like for me to know if the students are getting it correctly, if they have the correct perception of my explanation. Not until I see it in the quiz, in the test. And by that time, it's almost too late, right? I mean, the misconception is already there. Whereas if they are the ones who are articulating the explanation, like I think that is better. Then at least like I can catch the misconception right away.
Right. I think getting them to articulate clearly, getting them to write frequently,
That's right.
is really helpful. I've used POGL activities for quite a while in my teaching, and they're similar
Absolutely.
to the activities in AP Insight, and that just getting students to and pushing them to write a complete sentence or a complete thought on some of those questions, not just a one-word answer, but really getting
Exactly.
them to go beyond their comfort zone.
That's correct. That's correct.
I
Would
agree.
it be the same? Is it the same for you, Stephen and April? Like the challenge for me is really the time. Like there's a lot of like activities in AP Insight and in like Poggle Law, so wherein you actually involve the students like to have like pair share or like discuss in small groups, because that is when their perception of the concept is going to come out. But if I'm pressed for time, usually now what happens is that I give it as homework, and then we just like discuss it briefly. I would have wanted to have like more time in terms of like discussing and like validating each other's perception of the concept, basically.
Right. Yeah. I'm not sure there's a teacher on the planet that wouldn't want more
Yeah,
time.
yeah,
Right.
I agree.
that's correct.
it's walking that fine line of trying to figure out, all right, how much of this can I afford to discuss and go into detail on, and hear them kind of respond with their answers, and how much do I need to move this bus down the road so that we are able to cover all of the material that we need
And
to
I think
cover.
the other side of that, Stephen, is the whole lab component, because for me, I have 48-minute classes. So to try to get a full lab done in a 48-minute class time is almost impossible. So I've been trying to flip myself a little bit, where I'm giving them a lot of instruction outside of class, so when they come back into class, they have time to apply it. And that seems to be working okay if you've got students who are motivated enough to go outside and do that. But when you don't, then it becomes a little bit of a problem. And so I think it is a time frame. And I'm in Kentucky, and so we have a program called Advanced Kentucky that helps sponsor some of this stuff and really encourage us to do things. And the person that's in charge here is saying, labs are important. Get them doing the labs, get them explaining it and seeing it. And I'm a firm believer in that. It's just sometimes some of those labs are a little bit higher functioning than I'm comfortable with just letting them explore with sometimes.
Sure. And it's going to vary week to week or year to year, and depending on the students as well.
That's right.
So let's just give a brief overcap here again of AP Insight. We're all familiar with it. It's the instructional resources, and it's the assessments for learning, and it has some of these tools that we're talking about, and I think it can even help buy us back some time, if I can be so bold as to say that, because of the tremendous feedback that is available within the platform. Right? It kind of multiplies our efforts a little bit, and the student gets the feedback that we might want to give each individual student, but in our classroom we just don't have the time.
That's right.
Right, so there's a lot of formative assessments, with AP Insight. That's kind of the backbone. There are the building block quizzes. There are the challenge area assessments, which is what we're going to focus on tonight. And that's really where we deal with and identify the enduring understandings, and it really helps us kind of pinpoint if our students are really understanding, or if they just have some knowledge that they're carrying along with them. And so we'll look at some samples tonight of some student responses, and we'll analyze them. Does this student really know what they're talking about, or are they just spewing back some facts that they hope applies to this situation? So we'll get there maybe in 10 minutes or so. But if you've had a chance to use or look at the challenge area assessments, they're usually 3 to 4 free response questions, and they're built to mirror the questions on the AP exam. You might as well get them familiar with that format at the beginning. And there's the long questions, and there are the short questions. So the bold-faced line there, as I read that, I thought, wow, that looks, in my mind's eye, I see that concept map from the Welcome to AP Insight webinar. I don't know if you guys remember that, but being a presenter, I've seen it many, many times, where it's got all of the challenge areas listed in circles, and then there are all these arrows connecting challenge area to big idea, 1, 2, 3, 4, 5, and 6. And that's what makes some of AP Chemistry so challenging, for lack of a better word there, right, is that they are making connections all over the place. And so they can't just rely on knowing the facts. They've got to be quick on their feet. If you've used challenge area assessments, or if you've just done POGIL-like activities, when would you assign those activities? When do you assign those in kind of the normal flow of your classroom?
Well, I think the POGILs for me come in handy when I'm trying to get a topic across without formally just lecturing, and I want them to sort of discover. And I would think that, unfortunately, not having used a challenge area assessment just yet, I would probably assign that after I've done a little bit more formal understanding on those other small quizzes and seeing how they are doing, to see if they can then now apply and transfer that knowledge that they've gotten from what they've done to this challenge area assessment.
Yeah, I think that's good. That's kind of how I use them in my class. Right, I often will use a POGL type assignment as an introductory, just to get them thinking, so they're not dependent on me to kind of spoon feed every bit of information and every part of the thought process, and then working through to a challenge area assessment.
That's what I do also. I'm sorry.
Can you all hear me? Okay.
Very, very faintly.
Mm-hmm.
Okay, let me see if I can turn up the volume.
Okay.
Oops.
You should have a link to turn that volume up at the top of the window.
Is that better?
Yes, much better.
That is better. That is better, definitely. Welcome.
Thanks. Sorry to be late. I was just going to say I've found the multiple choice quizzes really easy to assign, but I'm struggling to figure out when to assign the challenge area assessments, just because they combine so many different pieces.
Right.
In my
during review for the AP exam in April.
Absolutely, I think that's a good time, because you've definitely gotten through all of the content that that you hope, right?
Yeah.
that those questions are connected to.
Yeah, like can I just share my experience with the challenge area assessments too? Like the performance tasks, these are like the Podio questions that you were like talking about, Stephen. Yes, I used that like during the discussion of the concept, introduction of the concept, and as we build on the different items for the concept, and then the building block quizzes. I either assign those as homework or as like classwork, and then we discuss the answers. And then the challenge area assessments, I don't give the whole thing. Sometimes there are like there will be like 2 to 3 or 3 to 4 big challenge area assessment questions. Sometimes I will just choose number 2, for example, or number 1, for example. But I usually do it before I give the actual test, like the chapter test or the chapter test. Basically, that's how I use it, because as I said, like I guess my classroom is different because we are on a block schedule. Ideally, yes, I would have waited until I review them in April, but by the time it's already like voluntary for them to come to me, they're not mandated to come to the review classes, and then I cannot like grade them. When I'm doing the challenge area assessments during the semester, at least it is still like, I mean, they are like sort of like motivated to like really work on those questions, because it's preparation for the test, for my chapter test, basically.
Right. So hopefully, I'm sure, Maria, you've seen a difference, or I'm hoping you've seen a difference of running your class without AP Insight and then running it with AP Insight as that tool to help you review, because you've got a very unique situation.
Yes, definitely. Like the impact in my scores is really phenomenal, such that like, I mean, I didn't have any trouble like asking my administrators like to get AP Insight again this year.
Oh, that's great.
So, because I mean, like, because of the schedule that I have, like in the past, like the scores were not really that good. Like, I mean, because I see them like until end of January, and then I will see them again like 2 weeks before the test for the review, which are not even mandatory. It's voluntary, so whoever comes. That's it. They're not graded for that. Right. And then the other thing also is that the fee for the test is free. So I mean, so anyone can take it. They don't have to pay for it.
Very good. Very good. Did I hear someone else with a question or a comment in there? Nope. All right. So let's keep moving. Um, so those challenge area assessments are located in the Assess tab. You're going to choose your challenge area, and then toward the bottom of the screen, you'll see where to, assign. You can assign the challenge area assessments, and in there's also the link to the teacher guide, which I'm assuming you're all familiar with. So let's jump into one of these challenge areas now. We're going to look together at the challenge area represent and model entropy. And hopefully you've had a chance to download the participant handout. And if not, there's a link in the bottom right-hand corner of the window. And you may want to open that up just so that you've got a larger view of some of the slides that we're going to go through here in a few minutes. Right, but this challenge area deals with a specific learning objective. The student is able to use conservation of energy to relate the magnitudes of the energy changes occurring in two or more interacting systems, including identification of the systems, the type, or the direction of energy flow. And the enduring understanding is that energy is neither created nor destroyed. And then maybe as those ideas come to mind, put them in the chat box, maybe rather than discussing them out loud for those of us that might still be reading through the question. Right. I'm liking what you guys are putting in there. I think you're really getting to the heart here of what they need to understand. Right. There's a lot of stuff here. Right. They're not just plugging things into an equation and churning out an answer, which is what most of my students would prefer to do, rather than have to think sometimes. Right.
Yes.
You know, April, the first thing you wrote there, students must understand that heat gain is equal to heat loss. And we would think that would be a simple concept, but how many times have they missed that concept in trying to solve a problem similar to this one?
Still struggle with it. You're right.
Right, and if they miss that foundational concept, then it's very difficult, if not impossible, to continue on with any of the parts of this problem.
Right.
So let's look at some student responses here. Unless anybody else has anything else to contribute here about what students might need to understand.
In this too, though, like it's not just conceptualizing. That third one, that's a big multi-step calculation.
Yes.
To figure out how much heat the iron is losing, and then how much heat Are you assuming they're all getting to 25 degrees as the final temperature, or?
Well, that's certainly the temperature they've got to get to before. Let's see. Hold on. No, they're not getting to room temperature, right? We're assuming they get at least to the freezing point, whichever one of the three alcohols.
Glycerol has to absorb to get to the freezing point.
Right.
Mm-hmm.
Or has to release to get to the freezing. Has to lose to get to the freezing point, and then how much more? So it has to go from 25 to 18, and then it starts to freeze.
Right.
Mm-hmm.
And then how much energy does it lose in the process, and how much of it actually freezes? So let's look at some student responses to this question. So here's a student response to part A, which is which liquid will have the greatest change in temperature? Then explain your answer using information from the table. So what level of understanding does this response demonstrate? Again, if you can't read it here, perhaps in that PDF it's a little larger, or at least you can make it a little larger.
Could you repeat your question again, Stephen?
So
no, their student's wrong. It's backwards, right? They've got it backwards.
So we have, let me back up for a second. We have on the screen here a student response that says ethylene glycol will have the greatest change in temperature because it has the lowest specific heat. This means that it can accept more heat than the other alcohols.
The first sentence is true, the second sentence is not, I think.
I'll let everybody else join in here. What are you thinking?
Am I?
Would it be it will be more acceptable to just stop after the first sentence, like after when the student wrote the second sentence, he or she demonstrated that his or her understanding of like specific heat is not that clear.
I think, right, perhaps there's some understanding here, but that second sentence is, maybe not the best. Maybe shoots himself in the foot a little bit here.
Mm-hmm.
Yeah,
But
they understand the mathematical relationship, but they don't understand that they all have to absorb the same amount of heat.
Right.
will writing just the first sentence will that like earn full credit? Like, will saying that because it has the lowest specific heat, will that be enough explanation to get the full credit?
I think that would be, yes. If you look at the rubric for this, the teacher guide, because it has the lower specific heat, right, is the justification that they give. All right, so we've got some understanding demonstrated here by this student.
Mm-hmm.
All right, and then they go on in that
Agreed.
second sentence, and they're unclear at best.
Mm-hmm.
Perhaps if they included a little more information there, a little more to that, another sentence, they might have been able to wrap it up.
Mm-hmm.
Any other thoughts on this student response?
Some students may be confused by the other information given in the chart. Like say for example, okay, deals with temperature. Will the freezing point be relevant in terms of like answering the question?
Right. They've got to certainly be able to pick out which information to use to help justify their answer.
Mm-hmm.
Right. I mean, they could guess one of the three, and maybe they would guess right, but then without the explanation, they really don't have a leg to stand on here.
That's correct. Mm-hmm.
So let's look at another student response here. And this is also for Part A. And this student has responded that methanol has the highest specific heat, so it will have the greatest change in temperature. So what level of understanding does this response demonstrate?
None.
Little. Yeah.
Right, they've got it backwards, don't they?
Yeah. Mm-hmm.
Right? They might have some understanding in that they knew to reference specific heat, but they didn't know how to handle specific heat properly to come to the right conclusion.
Mm-hmm.
Right.
They could have chosen oddly molar mass or enthalpy of fusion,
Mm-hmm.
but they at least knew to choose. They at least knew the right thing to choose in terms of supporting their argument.
Mm-hmm.
All right, let's move on to Part B. Right, Part B says the iron samples are very cold when they're placed in the alcohols. Explain at the molecular level what causes the iron and the alcohols to reach the same final temperature. And I'll have a student response here. Student response says the iron samples are cold because the molecules have a lower kinetic energy than the alcohols. When the iron is put into the alcohols, the molecules will begin to collide, and eventually the iron molecules will slow down, while the alcohol molecules will speed up, and the two will be at the same temperature.
Yeah, that's opposite there at the very end.
Let's have a look.
She says at the top that the iron molecules are lower in kinetic energy, but then at the bottom, or this person says at the bottom, that they will slow down.
Right.
While the alcohol speeds up. So there's a misunderstanding. And the first statement is correct, but the bottom statement produces a misunderstanding, and I'm not sure if this would be counted correct just because of that.
Right. And what might be correct in your classroom or through a conversation with the student of think through this question again, and here's where you started and here's where you ended up. I mean, this would be great kind of food for conversation with that student. Take a look at this answer. Let's look through it again, and maybe they just got confused, right? And you switch two words here. You switch the iron and the alcohol, and you've got a correct answer. You've got cold to faster, and you've got a better answer. It's hard to know what this student actually does and doesn't understand.
Right.
Right, because it's such a fine line there at the end. I'm sorry? Say that again.
It almost looks like they were just trying to answer too quickly, and they got it switched in their head and just kept going.
Right.
It is as if like a student have the perception that, okay, I will like mention kinetic energy and my answer should be correct then, without like fully explaining it correctly.
Right. And they certainly started well.
Mm-hmm.
They certainly started well. All right, let's look at another one. Since the iron molecules are cold, their kinetic energy is low. When you put the iron in the alcohol, collisions will occur between the molecules, causing the iron molecules to speed up and the alcohol molecules to slow down as the energy is transferred. This causes the iron and the alcohol to reach the same temperature. How did this student do?
I think this is a better answer than the first
That's a
one.
pretty deep understanding, yeah.
Mm-hmm.
Yeah.
Right, they don't get things confused here.
Mm-hmm.
You lose credit for referring to iron molecules, because they're not technically molecules, when the question asks them to talk about the molecular level.
That's a good question. I would probably say no, that they wouldn't, that would be kind of minor in the grand scheme of things. Yeah, we do want molecular level, but I'm not sure that's enough of an error to take away a point or two or whatever this might be worth on the test.
Yeah, Stephen, I have another question about this being like about the particulate level or molecular level. Because the way I've been teaching it in my class, usually when the question deals with like particulate level, molecular level, you will have a picture of the ions, for example, like dissolving of like sodium chloride, it will be surrounded by water molecules. So when a student sees this particular question, they're thrown off. Explain, am I supposed to like draw particles in here, but it has to do with energy. So how will I like draw it? Do you get what I'm saying? Like, so should I like change it in the way I teach it in my classroom? That when you say molecular or particulate level, it's not just about like drawing circles and charges. Instead,
I think you could do it the same way you're doing it. And what I teach my students to do when we're trying to talk about kinetic energy or the amount of energy is to use like vector arrows to represent energy. And so you could use small short arrows to represent the iron and longer arrows to represent the alcohol. So I think you could get credit for this by explaining it with a drawing too. I think my concern here is that the original question did ask for an explanation and not just a drawing. But tell me if I'm wrong, Stephen, on the AP exam, if a student were to draw that picture and draw arrows, shorter arrows for the iron and longer arrows for that, and then later on draw that they're both about the same, would they be getting the same understanding and be given the credit for that?
Oh, great question. I'm not, to be honest, I'm not sure on that. There would, that's a discussion that would happen not just with two people, right? There would be a team of people that would kind of discuss that, and how you would come to a conclusion on a very unique answer to a question like that would be challenging. I always tell my students that pictures are worth 1,000 words, but if you're going to give me a picture, also give me some words to explain that picture, so that what you write on as your answer, so that I know how to interpret what your picture is, because the picture that they draw and the way I interpret it might be two very different things, and right or wrong, right? They could give me I could interpret it correctly, or I could interpret it incorrectly from what they'd done. So I always tell my students, give me some words. Make it easy for me when I grade it.
At the very least, like even like phrases, Stephen, you're saying, right? It may not be like complete sentences, but at least like phrases like a what do you call it? Like a label for each particular diagram with a vector showing that it's long. What does that mean? Am I correct?
Right. And because there's not necessarily a standard way of drawing a diagram like this, right?
That's right.
If there were sort of a standard, sort of typical answer and way to express this in a diagram, then that might be something that would, fall toward a point. But since there's not really sort of a standard way of representing this, definitely give some words.
I was just going to say I also teach AP Bio, and in AP Bio they're very explicit that if the question doesn't specifically ask for a drawing or a diagram alone is not a sufficient answer.
Okay.
Like, use it to supplement your answer, but it's not an answer by itself. I don't know if that would apply in chemistry, but
it probably would. I think that's probably a great rule of thumb.
Mm-hmm.
Yep. All right, let's look at another one. We'll look at something from Part C here, the big calculation. And so again, that PDF that you downloaded will be really helpful now because at least it's very small on my screen. So it's a pretty challenging question, right? The student's going to have to really work hard and demonstrate a lot of understanding to earn this point. So what do you guys think about this one? Deep understanding, some understanding, or a little understanding?
Really good understanding. They got there faster than I did.
It's almost too good. Makes you suspicious, right? Right, yeah. If I had a student give this kind of answer, I would be overjoyed. Right? They organize it well. They communicate it well.
Yeah, either that or they Google the scoring guidelines.
Right, they're very clear in their answer.
As a reader, Stephen,
Exactly.
Should I be telling my Stephen, as a reader, should I be telling my students also, for each particular step, it's not enough that I will just start with Q is equal to MC delta T. It would really be helpful to say what this student has done in here to bring iron to freezing point, and then you have the calculations. To bring glycerol to freezing point, and then you have the calculations. Will that be better as an answer instead of just writing all the equations?
So I guess there are a couple of things here. Do they need this much detail? Right? Do they need to say to bring iron to the freezing point it took this much energy? Probably not. Is that really helpful for them in organizing their answer and helpful for me as I grade it?
Mm-hmm.
Absolutely. Absolutely. Do they need to include every line of solving? Right? They've got 4 lines with each calculation there, at least in the first 2 steps. No. Show me the equation, plug in your show me how you plugged in your values, and then give me an answer.
Mm-hmm.
Right?
Okay.
Because a lot of points on the exam come from, not a lot, but some of those short answer points come from, do they know what information to plug in, appropriately in each spot? Right, and do they show that?
I do find those, Stephen. I was going to say, I do find those, Stephen, that my students in particular have a hard time following calculations unless they have a pathway sort of kind of thing, and I feel like this gives a pathway. This reminds me of how we used to write lab reports in, college chem. When you had to do the analysis section, you had to write what you were doing and then write it out. And I try to teach my kids that because I feel like they need some way to follow what they're doing in a way. And I really like this because it's very clear on exactly how she did it.
That's right.
Or
Yes,
he did it.
Absolutely.
She, but
Absolutely.
it's so neat it has to be a she, right?
Right. Do you all use the student responses that are available to you on AP Central? Because that I've found that's a great. They have sample student responses for each of the short answer questions from the previous years, and I've found that's a great way for my students to be able to see what a good answer can look like and to see what a bad answer can look like. Right? And if this one were there, wow.
Yeah, I was thinking about doing that during my review time in April, bringing in those questions and having them answer them and then looking at other student answers to see how theirs compare. I think that would be a good use of time for me. So that was the plan.
All right, that would be another way not only to help, because I think some of our students understand the concepts, but they have a tough time getting the what's in their brain onto the paper. And sometimes seeing those sample responses is really helpful.
I agree.
So let's look at another student response here. One that may or may not show understanding, and let's hear what you think.
I think it shows understanding. I think the problem is in the second problem with the glycerol, they used the wrong specific heat.
Yes, they do.
So their final answer is incorrect, but it looks as if the math portion is correct. I mean, it's not exactly the same as the last one, but you know, they are getting to the right idea.
Yep. Any other thoughts on that?
I mean, even without the description, it's pretty straightforward too. You can follow like the logic of the calculations.
Right. They've laid it out well. Right. They got 32 joules in their first set of calculations there when they should have had 49. So they had some concept of what they were doing. They then used that with the heat of fusion. Right. Remembering to convert to joules. Which was good. How about any of the other subsequent steps down there? Do they have those laid out well?
The units are all canceling and everything.
Yeah.
Right, the units all look reasonable there, sure. So they've got some understanding. They might have a whole lot of understanding, and maybe just grabbed the wrong specific heat.
What would be the score of this particular response, you think, Stephen? Like just -1 if it is like a 3-point type of question? Or at least like 1 out of 2? Is that how it's going to be at least?
That's probably a fair assessment, right? This probably would be a 3-point. In my opinion, this would probably be a 3-point problem, but you know, and they do demonstrate definitely some, right? There's somewhere between some and deep understanding on this.
That's correct. Yeah.
You know, so what that scores, you know, I'm at yeah. We'll go with 2 out of 3 points maybe.
Okay.
On this, right? I don't think I see any other glaring errors.
I mean, down at the bottom, the second from the bottom line, there's something that's unnecessary, but when you come
Right.
down to the very last line, they bring in the 18,300 joules back in. And so in reality, the only mistake that was made is that they used the wrong specific heat at the top to get the 32 joules, but then they used
Right.
that at the bottom to get the 0.16. So I agree with you, Stephen. I would say you'd miss a point because you got the wrong specific heat.
Right. Now, let's see. I think they also do have some sign mistakes, right? Because the Q for iron should be 217 joules. If we go back, I'll go back to the previous students, right? The Q
Okay,
for
yeah.
iron there was 217. So they do have another mistake in there.
Oh, because the iron is starting at negative 78.5.
Right. It's
You're
starting
right, yeah.
at negative 78.5.
You're correct.
So
yeah.
they do have another mistake in there. And they wrote, I guess, 12.43 instead of 2.43 for the specific heat. So, yeah, maybe we're downgrading this to closer to some understanding rather than creeping toward deep understanding, right, as we look at this a little more closely. All right, so how do we as teachers then help students develop enduring understandings? right? We want to get them there. We know a little bit from analyzing those whether they're there or they're getting close, right? But how do we start from the beginning to get them there, right? And one of those things is simply being proactive and being able to anticipate some of the issues before they arise. And so another one of those valuable resources on AP Insight are the resources that kind of lay out the student misconceptions, right? When you, on AP Insight, when you go to the Unpack the Challenge Area feature, and it kind of walks you through step by step, there's also a PDF document that you can download that has student misconceptions, right? As you go through this and sort of tab through it, or click through it, right, it outlines why this area is hard to learn, right? What is it that students have difficulty, right? What connections do they have difficulty making? And how do they struggle with justification? So some of those resources that are there for us as teachers are going to help us kind of head those things off at the pass, maybe even before they start. And if you've been teaching AP Chemistry a while, you anticipate some of those anyway. But sometimes sometimes I don't anticipate all of them, and students catch me by surprise, and I think, I forgot to, emphasize that, or that surprised me that they didn't understand or weren't able to justify that kind of question. And then that guide also talks about why it's hard to teach, right? And maybe some resources there so that we can sort of brush up on that topic so that we can teach it more effectively. Right? It's an abstract topic there, as it says, right? Maybe our background isn't as rich in the particular topic. Right? Students are going to have difficulty defining the system and the surroundings. That's a constant struggle. And then poor math skills. That often will hamstring a student. Right? And we might have to spend a little more time reviewing the math with them when we'd rather be teaching the chemistry. So how can we use AP Insight to develop those understandings? Let's see. The success criteria packets. Have you all used those in your classes at all?
Some of it.
No, I have not.
Some of it, but not all.
Okay. Right. So sometimes the success criteria, right? That's just simply a document in AP Insight that sort of tells the students where the bar is in this particular topic, right? What do they need to know? What are the key concepts? What are the main ideas that they need to know in that particular challenge area? Right? Success misunderstanding number 4, and so it will help line up those misunderstandings with the success criteria. And I think that's valuable information not only for us as teachers, but for our students as well. Some of it also is so that our students know how to answer a question well and how to provide evidence and reasoning and support for their answer. Right, as we saw in some of those student responses, they didn't do a good job justifying, or they were unclear in their justification at best. Right? How do they approach a question when it says, explain this or justify that, or on a molecular level describe what's going on? Right? So that's, as we as teachers need to be kind of coaching them through that, and making sure that, on our tests and quizzes and other assessments that we're using questions that ask them to describe and to identify. Right, and then there's the feedback, right, which to me is the big strength of AP Insight. Right, it multiplies the teacher and tries to give specific, appropriate feedback to each student. And so it may take some modeling of how to use that well in the classroom, right? As the student, as we put in the scores from the challenge area assessments, and then the students can go on the website and say, all right, I missed A part 1. You know, here's maybe what I don't understand, and that feedback report is valuable. But students are going to take the path of least resistance sometimes, and it's, you know, they need to be required or held accountable sometimes to doing what's good for them. And so, do you guys have creative ways to get them to do those things that are just good student habits? You know, reworking homework, going back through a test, reworking the problem that they missed. How do you guys handle that in your classroom?
It's difficult, and it's hard to do unless you have a motivated student. And so the ones that are motivated to do well, they do it, and you can ask them, and sometimes they do it on their own. The other ones, you got to poke and prod. Sometimes you got to offer some incentive, like a lunch or something good, a piece of candy even sometimes. But, you know, I'm not beyond a bribe if I absolutely need to help a student do that. But at some point, they have to be able to want to do it too.
Right.
But I think, like, for my students at least, what they tell me is that they really like the instant feedback. So they don't have to wait until they submit the paper to me, and then I grade it, and then I like return the papers. Like for example, the quizzes. Like they answer it, and then they see already, oh, I'm wrong, and then there's like a rationale at the bottom. Like it would say, if you chose letter A, for example, this means that you have some understanding, but you have to like review this particular part of the concept. So the next steps, basically, it's not just for the teacher, but more so for the student. So right there and then, as soon as they finish that particular quiz, they know already what they got wrong, and then what do they have to do to like make sure that they will not make the same mistake. Right. I think for me that is very, very valuable.
So you're talking about the building block quizzes and the information that they can get from that, and I think. I think that would be very helpful to guide them without me telling them. You're absolutely right.
That's right. That's right. And then the feedback report also for the building block quizzes. At a glance, right away, I can see, oh, red. Oh, that particular question, we really have to go over that in class. And then this one is like 90% of the students are green. So, maybe I'm not going to be able to like discuss that anymore. But at a glance, I see it right away, what questions I need to focus on.
Right. Maria, I think you're hitting a very important point there in that the feedback is not only good for the students, but it's good for us as teachers. It really can inform our instruction, right? We can look at that and see quickly at a glance what we need to reemphasize, right? Or what we can just say, all right, you guys seem to understand this, we're going to move on.
That's right. That's right.
Right, and so using the next step guides with the reflection, just another tool, and that might be a way to hold the students accountable as they reflect on it, and they have to write up a simple report on what they got right, what they got wrong, and then next steps to commit to. And that can take as long or as short as you want it to in a class period, but it might be at least good documentation to say, you know, hey, Johnny, you knew you had this wrong, and this is what you said you were going to do to try to fix it and fill in the gaps. You know, talk to me about what you've done to do that.
That's right. Like it creates awareness in the students. Like I would usually sometimes I would assign the quizzes as homework, and then by early morning I have 2 or 3 students waiting by my door already, because they will say, oh, miss, I got this question wrong, and I know there's an explanation, but I need you to further tell me what I got wrong and why letter A is the answer.
Yes. Yep. I wish I had more of those students. So we've kind of reached the end here, and we'll take a few more minutes if you have some time, and I've got a few discussion questions if we want to throw some ideas around together. if you want to type them in the chat window, or if you'd rather kind of discuss them out loud. The first one being, which AP Insight resources have you found to be most helpful for you and your students in developing enduring understandings, and why would you rank that as the most helpful? I'm pressed for time, so I personally find that the building block quizzes have been some of the most helpful. I have very little class time with my students, and so a lot of it has just been the building block quizzes. Maria, it looks like you use the performance tasks for each challenge area. That's getting deep into it.
Yeah, like for each building block, there's like these are like the Poggle, is that how you're saying, like the Poggle-like questions that you were talking about in the beginning, Stephen? I think like it is very, very helpful for me because like the way it is laid out already, like the questions are designed so that the students will build their own understanding instead of me like just explaining it and then just hoping that they will get it. Instead, like the topics are like built on top of each other from more simple, starting with simple concepts and then moving forward to complex concepts and then like connecting it to other areas basically.
Mm-hmm. Good. Has anybody else been able to use the performance tasks? Let me read through your responses here.
Yes, Cicely, like especially the mass spec and the photoelectron spectroscopy, which is very new. There's not a lot of like material on that. Like I don't see it in Sundog. But the photoelectron spectroscopy in the atomic, the first challenge area, that is very, very helpful. The early atomic models, the early atomic models, the second building block in there. Let me I'm gonna go to my AP Insight.
Yeah, I have the Moog and Farrell book, and they do a lot with PES, so I had that covered pretty well. But
excellent.
I didn't really have anything on mass spec, so I was sort of looking around, and I had a little thing I had written, but it wasn't very good, and I liked the one in AP Insight, so I was really happy to have that.
Mm-hmm.
Good. It was helpful with your students?
Yeah. Well, I thought I only used part of it because I thought the first two questions, it was like 4 parts, and I thought the first 2 were kind of, at least for my kids, were stuff that they already knew or was a little too simplistic. But the third and the fourth part I really liked.
Yeah.
Good.
I don't remember too many more details than that, but I remember I used part of it.
Yeah. And then Cicely, I think also in that particular performance task with the mass spec, I know this is like really simple activity, the observator and like you give the students like a mixture of pre-1982 and post-1982 pennies, which I'm sure all of us have done in like first year chemistry.
Right, yeah.
Yeah, I like those. Like I like those with the performance tasks. Like it starts with like an activity, a demonstration, so that students will be hooked into the concept, and then they have to answer like questions pertaining to the demonstration or the activity.
All right, so we're kind of running short on time. We've gone a little bit over already. So there's a survey that I'd like you to take at the end, so if you can hang on for a few more minutes, that would be great. But if you have any specific questions for me, let me ask that you kind of stay on for a few more minutes after we get to the survey part, and I'll be happy to try to answer those. All right, so I'm sure you're also aware of the Share What Works, the discussion board, professional learning community on AP Insight. So I'll encourage you again to use that and to browse the resources that are there. And then here's that link to the survey. So if you know, before the night is over, if you would open that in a new tab now and do that survey, I'd greatly appreciate it. So if you want to hang around for a little bit more and have some discussion, that's great. If you have specific questions for me now, fire away. I'll do my best to answer them. So thanks for joining us tonight. I hope this was helpful and beneficial and giving you some next steps to take with AP Insight. I didn't realize that this survey was part of the information used for CEU credit. So that is a new line in the survey slide there that I didn't pick up on. I probably should have mentioned that at the beginning. So there will be another PLC in February. So stay tuned for information about that. I don't know the topic, but I'm sure it will be a good one. So I'll be online for another 5 minutes or so. If any of you have any more questions. If not, thank you for joining me. I hope this was a profitable experience for you.